the session.
Thank you, sir. When technology meets the field, agriculture evolves from tradition to precision. So, Jai Hind and good evening to everyone present here. A very warm welcome to Day 28 of Society for Agricultural Advancement, Research, Training and Human Innovation. Knowledge Revolution in Agriculture, Nurturing Technology and Innovation 2026, our 30-day national training program. On behalf of Agri SAARTHI team, it is my immense pleasure to welcome all the participants, esteemed resource persons, and our Chief Secretary today. I am Chatrisha. Along with me, Musina, we are from Agri Sadi team and will be coordinating throughout the session today. Before we begin, I would like to invite our esteemed guest, Dr. Megha Pradeep ma'am, to join us today's session. We are honored to have her and her presence with us today. And I would like to extend a very warm and respectful welcome to Ajay Khasana sir, the Chief Secretary of Society for Agricultural Advancement, Research, Training and Human Innovation, and Editor-in-Chief of Paris Publication. He is a visionary behind Agri Saradi, a platform that is dedicated for agricultural learnings, sustainable development, and practical learnings too, including the initiatives like 30-day national training programs. So, to briefly recap yesterday's session, we have discussed the genetics, plant breeding, and agricultural technology. We have explored how modern breeding techniques and innovations are helping us to improve the crop quality, productivity, and sustainability, laying a strong foundation for the lecture of future today. So, today we'll be focusing on the exciting and transformative area in agriculture, the drone technology. Drones are revolutionizing farming by enabling precision herbicide spraying and crop monitoring. They help farmers in saving their time, reducing the cost, and making the agriculture more efficient and sustainable day by day. So, to help us to understand on this topic better, we have honored that and an expert in drone enabled agriculture, Dr. Megha Pradeep ma'am. Dr. Ma'am is a triple alumna of Vasantrao Nayak Marthwada Krishi Vidyapith, holding a PhD in agronomy and with over 18 years of combined experience as an associate professor and an extension. She has become a leading voice in precision agriculture and remote sensing. Her recent research in UAV based technology and drone based weed management is redefining how we have approached modern farming beyond researches. She has also authored over 12 research articles and 15 popular articles, ensuring that complex science reaches the hands of farmers. Her dedication to soil was recognized at highest level when she was awarded by Vasantrao Naik Puraskar by ICAR in 2018 for her outstanding work in rain-fed agriculture, a true saridi for the modern era. She joins us today to share her vision of tech-driven agriculture future. So please join me to welcome Dr. Megha Pradeep ma'am. Please ma'am, the floor is yours.
Thank you, the team Agri SAARTHI for giving me opportunity to communicate with the trainees. And as a part of your training, this is a bit of contribution from my side. And today we will just have a look about the application of drones in precision agriculture. This is a bit wide area, which is the precision agriculture. Precision agriculture, if we apply, it is the right 4R principles are there. That is the right place, right time, right method, right source. And these 4Rs are uh, applied over the agriculture for the precision. Precision we attain with the efficacy in the resources, and we get the maximization of the profit and attaining optimum yields. These are the some precision agriculture basic understanding, and we are going to apply the drone in that. And in precision agriculture, the most important technology is variable rate technology. As we know that precision agriculture is basically of two types, that is the sensor based and map based. So here we will be discussing with the map based precision agriculture and use of drones in this precision agriculture. Firstly, we will discuss the about the what is mean by the drone, and when it was accepted, or when it was invented in 1985, the Yamaha company, you may be surprised, in Japan introduced the first UAV, that is the RMAX model R50 in agriculture. Now, at present, the drone market is very vigorously growing, and this is bit more than 200 manufacturers are there in China, and China is a leading country in the drone market. And previously, it was the talk like that, oh, what is the need of the drones? We are enough with the tractors, and what is the need for these drones? Farmer even don't know how to operate it, but we have to catch the speed of international level. Then we have to accept the drone technology, and we have to accept the drone policy. So it was the pressure on the government to be ahead or in a race at international level, where China was already manufacturing more than 200, was taking a lead. And at that time, we were just learning about the drone. So, but Make in India is a good initiative by the government of India, and in that there are so many companies that are taking part, and they are preparing indigenous our own drone. Though the parts may be imported from China, but they are now assembling the parts, and this way they are being the part of the drone market. Okay, it is better than nothing. Okay, it is something is better than nothing. It is the initiative was taken, but at the time it was literally very criticized that what is the need of drone in agriculture, but it is essential, because world is going ahead, and we should catch the speed, and we will match the speed of the world. Okay, we are going to be a economy that is fourth in the world, and we also need not to lag behind in other markets also. Okay, and this most of the UAV that are being with the capacity of 10 kg to 50 kg, which are the load load taking capacity, or that are the unloaded capacity, they can carry or they can lift the load up to 50 kg. Okay, and their operation height ranges from the 1 meter to 5 meters, and some drones are there, they can go up to high, but those are the surveying drones. Okay, we'll see the different types of drones also, and parts of drones also, and the working speed less than 8 meter per second. They have different parts, that the electric motor, tank, load ranging. It may be the tank which is assembled with the drone, is having the various capacity from ranging from 5 liters to 30 liters. As you see the drone use and its advantages in agriculture, you see that drone can be applied to a vast sector, starting from the plant genetics. Nowadays, if you see the drones, small drones are used as an pollinators for the flowering crops, where the self pollination is very essential, and to increase the pollination, and these drones are utilized. For drones, you can prepare the weather glitches. You can prepare for the weather glitches by avoiding the direct contact with the soil, where at the time where the soil is not suitable for agriculture operations. At that time, drones can operate, crop spraying can go, geofencing can be done, crop monitoring of the growth, plantation, soil and field analysis. Plantation, I to tell you that it was a person who have sprayed about thousands of seed balls in the forest for the tree plantation through the drone. Okay, the seeds were released from the drone tank, and they were spread over the large area, and this was done for the plantation. Soil and field analysis, it can be done with the drones. You will further see it. Livestock, for the livestock management also, drones are used for taking the observations for recording the movement of animals or the livestock. To check the crop health, we can monitor and check the crop health, whether the crop is under stress or whether crop is healthy. We can analyze with the drone, and these drone are highly efficient, so we can avoid the chemical overuse. So these are the drone use possible, which we can go for. So if you see the evolution of technology, you will see that the incremental benefits over the previous generations we get the past. We will the machinery, GPS track. Likewise, if you see the previous one, we are present and now the future. Past we used to the plow with the horse sowing husbandry, the famous book by Jethro Tull you must be knowing. We use the animals for doing our work in 19th century. In 1980s we get the genetically modified crops, and then we in 2008 we get the machineries, and that too with the GPS tracking. It was up to the 2008, but as we progress ahead, we are using drones, multiple softwares, we are utilizing satellite data, we are aware about the weather and their latest position and latest current position. We are all in our hands with the mobile or Android system, and this present we are going for the future, that is the new growth potential for the farmers, that we are going to data insight in which we are able to do the uh, various complicated agriculture operations within the very within a very uh, what you call a short time, and within a very uh, at your tip of the finger. You can do all the things by the plant sensors, Doppler weather forecast, and connected AG weather stations, and UAV with sensors and polypods. All these will give you a lots of data, and just you need a decision support system that will tell you what actions are expected to be done and what informed decisions a farmer uh, is advised by the system, and this will avoid a complete reliance of the farmer from the knowledge base, previous experience to the database. And this is the evolution of agriculture technology. We are becoming more smarter, we are becoming more sensor based, and we are relying on the data that is the realistic, and that too within a short time and over a large area. This is the most as technology is evolving, we are getting more smarter and more informed. Okay. And this was the Bharat Drone Mahotsav in 2022, where the Prime Minister has taken an initiative, and this was a landmark in the Indian history, where the drone policies were initiated, and all the drone related work was initiated through the support of government of India, and that thing lead to the development of the agriculture, from mechanization to atomization, and to the automation to the site specific management to the precision farming. Okay. Without site specific management, precision farming is not possible, and for the site specific management we need to know the variability, and variability is detected through the variable rate technology we apply with the variability analysis. And for the variability analysis we need different types of maps, different types of information data. That data we can receive a very short period through the drone. Okay. This is a very ambitious think that government has done for the revolutionization of this agriculture. Okay, if you see the top industries using drone, if you see the 42%, if you see the total out of it is the, sorry, a government is using only 1.9%, and the major is the utilities, and the next part is the real estate. Okay, if you see this, real estate is using 20.7%, and the major part which is the 42.9 is the photos, and photos that too we use for the wedding and different organizing some rallies, likewise, or taking some photo shoot of the sceneries, different locations. That is the mostly drones are used, but drones are really can be very useful for the scientific work, which is about 0.6 to 0.7%. It is only there for the scientific reason, and this is a very hopeful thing that we have a scope to increase this utility of drone in agriculture sector, which is presently a very less it is. Okay, it is only the 8% in agriculture. So we have a vast scope to increase the use of drones in agriculture. You see the global market of these drones. This is the CAGR rate, which is 21.3%. It is going to catch up to 2026. This is the highest CAGR rate of any commodity in the market, and the drone market is continuously growing, and the main lead nowadays it is the North America it is taking, and this market has shaken all the countries and made them aware about the drone, and that's why drone is inculcated or incorporated in the education system, so that our industry in the drone will be growing, and we will be a better competitor in the international market. And we particularly India, the whole world look at us like a hub of talent. Okay, and that's why the application of drone and incorporation of a drone in the education pattern or instruction system was very essential or unavoidable thing at that time, and it is really a good initiative by the government of India that they have initiated work on the drone. Otherwise, we will be a laggard in the drone, and still we are not much ahead, but we have at least started. Okay, this is a very big possibility and very big financial opportunity to grab the market, and that's why drone manufacturing make in India is being promoted by the government of India. Okay, you see drone, what is a drone? Drone is a simple aerial vehicle. Okay, it is a simple aerial vehicle. If you see the Mars rover that was launched on the Mars, this was a rover, and this is also a drone. Okay, it has sent a lots of important data of the Mars surface, and that data is very useful for the NASA, and that was a drone. Okay, for your information, I'm telling you. If you see the basically types of the drones, there are two types of the drones: fixed wings and rotary wings, and the stability of the drone and the capacity of the vertical and static flight. Vertical means if you see the aeroplanes, they need a runway because they cannot lift themselves vertically upward, but they need a pace to overcome the gravity force. Okay, but On the contrary to the drone do not need any runway or do not need uh, any speed match for that. They can be directly vertically lifted. Okay, static flight they will not, they will have a stable and static flight. That's why rotary wing UAV, particularly multi-rotor, are most commonly utilized for the chemical spraying. They are more stable. Okay, rotary wings. Fixed wings are not stable and they are not preferred because the rotary wings gives us directly vertical flight. Okay, you see these are the parts of the drone. We see the control receiver, this FPV transmitter. These are the propellers. They are maintaining the balance and they are maintaining the flight in the in a in the sky or in the atmosphere. Okay, flight controller is there, power distribution panel is there, electronic speed controller is there. Okay, control receiver is there, and FPV cameras are there. Here, additionally, we can have the GPS system mounted on the drone that will give you the GPS location also. Nowadays, if you see some drones are such that, excuse me, they will be having a setting that it will be flight from a particular location, then it will be coming down on the same position. Okay, you need not to go for catch it or need not to go it operate with the remote. Okay, these are some control systems and these are the parts of the drone. Okay, how to fly a drone? If you see the it is the quadcopter, it is there. Okay, throttle, pitch, roll, and yaw. These are the some directions for the remote operations. Okay, and green is for normal speed and red is for high speed. Move down if your throttle is up and down, moved, and pitch is forward or backward move, and roll is bend left or bend right, and yawn is rotate left or rotate right. These are all the control panel on the remote of the drone. This is taught, and this uh, drone handling is the you practically learn from the training where you can get the license of the drone pilot. Okay, and our university is having that licensed center for the drone pilot. Okay, this is how the drone fly. This is the drag and this is the thrust, and it is lifted upward. Okay, now this I will show you the total pressure counters. This is the airflow. Okay, the airflow always is having some certain pressure. We on the atmosphere also we have certain pressure of the air or the pressure of the atmosphere on ourselves. And if you see, these are the high pressure and this is the low pressure. Same, the wind is moving, air is flowing directly in a lower direction in the high pressure zone. Okay, and the wind is moving in this portion circular mode, and here they are straightly coming, pushing down. Airflow is pushed down with the velocity pressure, high pressure. Here it is, you see the Pascal pressure, it is the 10,000 sorry 1 lakh 1,600. This is the pressure, and here it is the low pressure. So that's why when drone is flying, you will see the lower part of the drone is moving very vigorously due to this high pressure of this airflow. And why this is generated? Because you see this propeller are moving. This propeller are moving, and below that propeller, the airflow is directed lower side because the the UAV or drone is maintaining its height in the atmosphere, or it is moving upward. At that time, the propeller throws the air below its, and then due to the throwing of this wind below the drone, this high pressure and low pressure velocity contours and pressure contours are being observed. Okay. This point is important for the suitability of the drone to the spraying, particularly to the selection of the crop. The crops having the tender stems, tender leaves, their attachments are very tender and fragile. At the time, this pressure may not be beared by the plants. And if the plant have very good flexibility, good stretcher, at that time, this airflow can be managed. Okay. Some of the agricultural, if you see the drones available in the market for the sowing, that is the DJI Aggress, that is octocopter. Means here you will see the eight propellers. Okay. And this is used for spraying of the herbicide, insecticides, fertilizers, and they can carry up to 10 kg of the liquid payload and cover up to 4,000 to 6,000 meter square area within just 10 to 70. Okay, 10 it can cover within 10 minutes, and if you see, it is 70 times faster than the manual spraying, and there are different different flight modes are there: smart, manual, plus mode, and manual mode. As we saw seen that the smart mode, here you can set your starting point. You can uh, uh, guide your drone for its movement. You can give him the boundaries, and you let him the spraying, that is the smart mode, or manually you operate the remote, or plus mode you add some other applications like stop the spraying where weed patch is not there, or spray the herbicide where weed patch is there. Okay, this way there are different flight modes are there with this DJI. Okay, this is the same with the DJI MG1. It's a battery. In drone, battery is the major issues that we have to do the recurrent charging with the drones. Otherwise, drones are very efficient in doing agricultural operations, particularly the spraying. Okay, if you see, the 65 to 80 acres area is covered in one day. That is not a matter of it is really appreciable when we require the manpower, and manpower is limited at the time. Covering a large area within a short time, that can be achieved with the drones, but only the limitation is that battery, that it requires the battery, frequent charging, and once you do the charging, battery will operate up to 35 to 45 with maximally 50 minutes. Then you have to charge the battery, or you have to keep the set of batteries, so that one battery is getting charged, one is utilized, and you keep it spare one. Okay, nowadays those who are doing the service, those are giving the drone spraying service, they do practice like this. They keep three or four sets of batteries along with them, so that their continuous operation of the drone is going on, and simultaneously they recharge the batteries also with the with electric supply. Okay, this DJI Agri 16, this is also very unique radar system it has, And this radar system, that is digital beam forming technology, which allows the 3D point cloud imagery, and that accurately senses the working atmosphere and assists in avoiding obstacles. Okay, if there is a tree in front of uh, uh, this drone, then it will avoid the obstacle. Okay, and this have the radar system that it can identify the obstacles so that it will not be a collision. Okay, this is a major of the issues with the agricultural operations, is that sometimes drone may have the obstacles of the bushy plants or big plants, and that may dysfunction the drone. But this DJI Agri 16 is very unique with its radar system. If you see that this is having 16-liter payload capacity, battery is relatively high, and spray width is 6.5 meters and spray rate is 4.8 liters per minute, and area covered is 10 hectares per hour. Okay, 10 hectares per hour. This is a very good drone. Now this NDVI upgrade, that is the Centera. This name itself denotes that it is built for NDVI maps, normalized differential vegetation index. You will get from this, and these are the cameras. They will take the images based on the spectral resolution, spectral reflectance. Okay, with the spectral signature, they will identify the whether the crop is having any stress, or it will identify the vegetation with a differential way. It will differentiate the vegetation also. From the all green cover, it can identify the crops and will differentiate the weeds. Okay, so that's why this is the smallest and highest, lightest smart farming sensor used to build NDVI maps, topography mapping, weed detection, location mapping, and crop density analysis. The flight planning is easier and covers large area precisely, so they are very popular. Now this parrot bluegrass field quadcopter. This is a very, very nice. I have seen up to the parrot has good quality and good support with the hardware and software. Okay, I really it has the software support system with the different mm, uh, software that will give you the analysis of the images, and it has the sensors like the from the flight will get an image, and from the parrot software you can analyze that or interpret that image. Okay, and this is a fixed wing drone designed specially for agriculture spraying in precision farming, and it is very insights for increasing the crop productivity and improving crop yield, and is simple and affordable price with an accurate camera to get high quality images. Okay, that's why it is very good if you want some images and simultaneously you want the uh, spraying also. Okay, means at the same time sensing and spraying both automatic way, you can go with the parrot bluegrass field quadcopter. Okay, it has a multispectral. Oh, now its sensor is multispectral and a 4th MP front RGB camera. Okay, this both hyperspectral and RGB cameras can be having the good bands that will give the different data sets for the different what you call data layers, and these data sets are able to identify different objects, and they can tell us the status of that object, like the soil moisture content. From the plant, it will identify the greenness index, nitrogen content, chlorophyll content. We can identify with the hyperspectral cameras. Okay, to even out of the simple features, it includes with such parrot fields mobile app. It is supported with a mobile app also, and that allows you quick understand the field operations and analyze the data of the crop. Okay, it is very handy that you can get the maps in the mobile and you can do the agriculture operations with the informed decision. Okay, these are certain others are also there's DJI Matrix 100 Acres, MG1 DJI Centra PHX, DJI Matrix 600 Pro. Nowadays there are so many others that are being identified by prepared by the China and local market also. They are there, but we have to look after the quality and the other issues like battery and the sensor quality and the drones that are being flight with they are whether they are standardized for the spray volume, spray rate, or the other spraying related operations or parameters. They are need to be tested, and they need to be what you call means if you see consider this Parrot and DJI, they are having already their own standards and they are very renowned. And as compared to local market, I don't want to discourage it, but when being a student, when you go for the uh, uh, practical and technical and scientific work and scientific study, you must have these things in your mind that the spray rate, spray volume, spraying speed, spraying height, again spray density, volume density, again the spray size and droplet size, droplet density, that all things needs uh, uh, to be provided by the manufacturer. Okay. Now in field we see the application of drones. This is the surveying type of drone. You can identify different patches that can be differentiated with their reflectance. Okay. Now this is the simple image. You can identify these two images and you will find certain differences in the color code. Okay. How these are the drone images. They are taken for the yield quality assessment. Sorry, uh, yield per unit area. Okay. Now if you see the green part, it is giving the more yield, and red part, this is the less yield. Okay, least yield. Okay, highest yield is from the higher green part. Okay, now this map shows the variability in the yield. Okay, the land is up till now, before the concept of precision farming, what was our concept? That the per unit area yield or productivity should be increased. Okay, how we can increase that? By increasing fertilizer dose, by increasing the number of irrigations, by increasing plant protection measures. Okay, but what we used to do previously, we were going for blanket application. Okay, we are not considering the variability within a plot. Okay, now with the commencement of the precision farming, and with the precision farming, we start analyzing the variability within a plot. Okay. Now this within a plot, if you see the variability, this plot may have given a better yield. Okay. Maybe 10 or 10 tons per hectare. But whether the every part is giving the equal contribution to that 10 tons, no, this dark green patch is giving highest contribution, and this red patch is giving lowest contribution. Okay, now only this green patch, with the green patch, it is giving 10 tons per hectare. Then if we eliminate this variability, then we can have a higher productivity, more than 10 tons presently we are harvesting. Okay, that's why variable rate technology we need to apply for precision farming. But how we should apply it? By detecting variability, by use of drones, we can capture images and images can be interpreted. Now, we capture the image. This is the NDVI or water stress may be there. We identified the variability. Now, this variability can be addressed. We can eliminate this variability and can attain this type of productivity. Okay, and this how we attain the precision in use of resources and increasing the yield of the particular crop from the particular land. Okay, I hope you understand here the variable rate technology, detection of variability, use of drone for detecting variability, and application of variable rate technology here. Okay, and variable rate technology is nothing but the basic application of the principle of the precision farming. This is the, you can see the cotton reddening mapping. Okay, this is the one concept that the one problem with the cotton is that due to two reasons, or it is a complicated reasons, that the cotton leaves get turned red, and they turn reddish, and the total chlorophyll content is reduced. And if chlorophyll content is reduced, then the leaf fall and bowl drop, both these problem arises. Okay, now the major reason for that is the magnesium deficiency. Again, the reason is that waterlogging is there, some microbial infestation is there. Okay, these are the some reasons where the reddening of the cotton is there. With the help of this study is in the from the Karnataka, the cotton field of 55 days stress NDRE map was done in the Kharif 2017, and these are the lesion that the severe stress, moderate stress, and healthy. If you see, these are the healthy plants. These are the severe stress. These are certain severe stress. So we can identify the stress. And now this is the drone captured image. Then that image is uploaded or is utilized, imported in the software, image processing software. And from the image processing software, we have the index, that NDRE. And this NDRE index, we will have the image analysis. Now, from this image analysis, we have the interpretation that with the help of lesions, you can identify that the severe stress are in the patches. Okay, okay, where they are in the patches. And the central part of this field is having healthy plants, while all the boundary parts are having the stress, reddening stress. Okay, now if we know the domain knowledge of plant physiology and agronomy and soil science, okay, this is the plot where the elevation is here, and these are the lower patches with the lower patches, okay, where the water stagnation is there. If you see, they have certain pattern. Okay, these severe stressed plants have their a severe pattern. Okay, this may be a water stream or a water channel must be going there nearby, where you will find the reddening, because the water standing conditions also increases the deficiency availability of the magnesium, and that's why reddening is there. The same part, if you see, these are the border types. Okay, border. This, there may be a wet patches in the field that may lead to the deficiency of the magnesium, and that's why the reddening of the cotton, that stress is being higher in these red patches. Okay, this image is taken by the drone, and from the drone we can identify the stress, particularly the cotton reddening, and this was mapped in Karnataka, and this is done with the help of drone. Okay, this way we can identify the plant stress. If you see, this is a simple thematic map that it will show the how the plants are growing and what is the this red, yellow and green, these patches. In this field, you will see this land as a whole, crop as a whole. But there is a variability in the field, and that variability is detected with this. Okay. Now, if you do a drone effect on the pest management, okay, you might be knowing that the drones were applied for the control of locust in the border area. Okay, there was a very huge attack of locust, and that locust were controlled using drones, and that was the most efficient. Okay, it was previously the application of uh, various chemicals were used to be by the helicopters and aeroplanes. Okay, they do not applied with the precision. Just they identified. They just come to know that at this village there is an herd of what you call locust. Okay, they move in a military way, like they will move in a thousands and millions, and they will cover all the field in thousands of hectares. Okay, now previously when there was a locust attack, always a locust attack have a typical pattern of the movement. Okay, they will move from Pakistan to India border, and they will encroach the total India. But if as we with our previous knowledge we know that this is a movement pattern of locust, we are able to control it. But previously, with the help of helicopters and aeroplanes, the chemicals were sprayed or were applied, and that was a blanket application. Okay, and this blanket application led to a environmental pollution. But yeah, in the recent last 2 years, the locust was controlled using drone, and that was a very precise where the locust were habilitating, and where they were moving. That track was only that particular part was sprayed, and that give a precision control and very quick control of the locust. Locust control, livestock management, and spraying. This is all the things we can do with the drones. Drones also do the flood survey, fertilizer spraying, and crop growth monitoring. These all the drone pictures. Okay. Now this is a comparative studies of knapsack, boom, and drone sprayer for the herbicide application, and it saves the time. If you see, the comparative work efficiency is higher with the drones, and there is a saving in the time, water, labor requirement, and agricultural operations. Okay, this is the research paper that was the published in environmental research with the NAS rating of 14.43. Okay, this is the research paper. It has the highlight that the comparative study of the comparatively studied, and this drone sprayer saved the herbicide application time and water and labor up to 85%, lower the weed index 9.1% was, and highest weed control efficiency of 82% was attained with the application of drone. And potential for it has a potential for site specific weed management and future research using drone sprayers with the remote sensing techniques. It can be integrated. Okay. This is the part of that research paper. This, if you see, the time requirement is very less with the pre and application by the drone. That is a 0.66, and only one, it is a 0.33. Whereas the application of knapsack sprayer, it is 8 hours are required. Then for the drone, one spraying, it is required only 0.33. Okay. This how water requirement also reduced. For 1 hectare, it was for the pre-emergence herbicide, 625 liters were required, and for the pre-emergence drone spraying, 25 liters was required. Okay. And labor requirement was also reduced. Only the two technical laborers to operate the drone and to refill the herbicide. This two person, one is technical drone operator and one is for his helper is required, and for the for the knapsack 4 man days are required. Okay. And 4 persons are required. You see the remote sensing using drone. With the help of drone, you can do the NDVI, NDDI, NDWI. All these indices can be calculated using drones. Okay. This how the this review paper is published with my student and myself, and it has the application of drones for weed management and control, comparison of the alternative spraying approaches with the drone, and analysis of efficacy of aerial spraying, and all these other health issues and other downsides and of the positive and downsides of the drone based spraying are discussed in this paper. Now, if you see the synergistic combination of the UAV with the knapsack, this study was done, and that was also promising when the uh, knapsack spraying as an pre-emergence and drone spraying as an post-emergence. The combination of pre-knapsack and sprayer application and post-emergent drone-based herbicide spraying exhibited the most favorable outcomes of the weed control efficiency, because the what you call critical crop weed competition period was covered in both these operations. Initial weed competition was controlled by the knapsack, and the after the 25 days post emergence application with the drones, that covered the 40 to 45 days of the uh, critical crop weed competition, and this has given the synergistic effect of the both combined use of both the sprayers. You see there is so many advantages: time saving, manpower saving, and it is the crop health monitoring is possible, planting and other we have seen in the second slide only. It has reduced the work burden. Within an hour, a farmer can complete his 1 hectare or 2 hectare. Oh, it will be accomplished. Then it need not to worry about other things, that whether the rainfall is there or whether the environmental conditions will be suitable for there, or whether the soil moisture is remain sufficient in the spraying. Within 1 day, it can cover a large area, and working in the damp and sloping areas where it is impossible for the human labor to go and work, their drone can do work. Okay. Vertical flight is achievable and low altitude performance is good by the drones. Drone can deliver real-time data. It will give the real-time data on the farms and allowing the farmer to make informed decision about the farm inputs. And use of drone for the crop surveillance can significantly increase the crop yield. This is a very promising thing, and that's why the it has a significant role in the precision farming. Certain disadvantages are there. Any technology comes with a high cost that may not be affordable to every farmer, but the price of the equipment is higher. require technical knowledge, and short flight period, that is 20 minutes to 1 hour, can be covered with the fairly limited region can be covered. Here it is a major, the battery issues is there, and herbicide pesticide tank volume is less, and most important that the civil aviation regulation you have to follow. And if you are in the green zone, then it is okay, but for utilizing drone you need certain permissions, license, and certain uh, permissions by the authorities, local administrative authorities. If you are flying in the drone in your field, you must inform your neighbors that we are going to do the spraying well before 24 hours before the spraying, to the neighbors, to the village administration. You have to inform it, and you have to take permission. If you have license, then only you can fly the drone. If you don't have license, you cannot fly the drone. Okay. And these are certain civil aviation regulations you must follow, and you must know if you are a drone pilot. Okay. Risk of drift. If the wind velocity is very high, at that time the drift of the because we are flying the drone above the soil surface or above the canopy surface, 1 meter to 3 meter. Okay. From ranging from 1 meter to 3 meter. Okay. In this height, there is a possibility that the the droplets which are dropping from the spray nozzle, they may get diverted due to the wind flow. For that, it is recommended that the drone spraying should be done when there is a and calm wind speed. Okay. And, it is not at all recommended that you should operate a drone in a high wind speed. Drone will not be balanced. Okay. It will definitely have trouble in maintaining its balance. Okay. Use of drone is affected by weather conditions, as we discussed. If the weather is clear, and then only we can operate. In the rains, in the storms, we cannot use the drones. Okay. Oh, there are certain challenges, that the gap in the laws and regulation governing the use of drones. Still, we don't know much about the drones, and lack of skilled person. We need the skilled person. So, at our Vasantrao Naik Marathwada Krishi Vidyapit Prabhani, we have initiated the RPTO, that is for the regional pilot training organization. We have this license, and we have the drone training center uh, at university, and the um, principal investigator, Dr. Gopal Shinde, he will be delivering your next lecture. He is the PI for that. He conducts the 6 month course for the drone pilot at his project. Okay. Now, lack of skilled persons, restrictions of the private and safe use of the UAV, unawareness of the relevant data analysis and drone technology. If you difficulty with the enforcement and implications, lack of suitable processes for purchasing and importing drones, you need certain permissions. Okay. And it is not at all allowed to import the drones. The procurement and import processes of the drone should be formalized. You have to do the formal procedure. Okay. There is a bright future for the application of drone, because it is time saving, less work burden, avoid the excessive use of inputs, reduce the chemical load in the environment, and it is possible to do the agricultural operations, particularly the chemicals, in the targeted area, and that is required attention. Okay. To bring the precision agriculture in the resource utilization more efficiently and enhance productivity, it can be helpful. And drones could be addressed as a green tech tool also, and it is gaining popularity in monitoring natural disasters. We have seen the images that the floods and other disasters like volcanic eruptions, they can be observed and they can be monitored with the help of drone. Drones are utilized to access the extreme damage and offer information on its impact. Okay. It is expected that the advancement of the drone technology in improving the image processing techniques, battery power, new camera design, low volume sprayers, nozzle type, flying time, low cost. These are some expectations from the drone industry or drone from the drone development and advancement of the drone technology. We want this modification, and that may lead to the smart farming in the future. Okay, this is the example that my student have done work with the drone sprayer. I sincerely thank NAHEP ICR New Delhi. I extend my thanks to PI NAHEP DFSRDA VNMKV Prabhani, Dr. Gopal Shinde sir. He is your next speaker, and I'm really thankful to my organization to give him for giving me opportunity to work on this recent and very what you call the cutting edge technology. And thank you all the participants for patientful hearing of my lecture. And I will ask host to have any question and answer session.
Yes, ma'am. Thank you, ma'am, for such an insightful and well-structured session on the application of drones in precision agriculture. Your talk clearly highlighted how drone-based technologies are transforming modern farming through precise monitoring, targeted input application, and data-driven decision making. Actually, the way you explained real field application benefit for farmers and the role of drones in improving productivity and sustainability was extremely valuable for all of us. And moving ahead, dear participants, if you have any questions or doubts, now you can share them. Participants may raise your hand if you'd like to ask a question or type your question in the chat box also. When you are invited to speak, kindly unmute yourself, briefly introduce yourself, and then ask your question. We request everyone to keep your questions concise so that more participants get a chance. Okay, we have a participants, Gautam. Gautam, you may unmute yourself and ask your query.
Good evening, madam.
Good
I
evening.
am V. Gautam. I am from Andhra Pradesh. I have a small doubt in how can a new student can join directly in the drone training.
Yeah. The next speaker, Dr. Gopal Shinde, you take his contact number. There is an official procedure will start for the admission, and you will get the admission. And the requirement of the admission, he will tell you the details about it. You definitely get his number.
Okay, ma'am. How many days, madam, total days of training?
6 months. 6 month training is there. Still, you will get all the details and exact update from him, because he is the person who is dealing all that thing.
Okay, ma'am.
Uh, Dr. Mega, till the time participant process the lecture and ask the queries, can you please connect with Dr. Sinde because we did not join yet.
Okay, have you shared his this link with him?
Yeah,
Link
I
with
have
him,
shared on the email and also on the WhatsApp.
and then he
Please,
must be joining. Okay, I'll
yes, you
just call
please
him.
follow. Till the time, participants, please ask your queries to the expert because it is a very relevant and new topic about the use of drones in agriculture. So, if it will be better if you ask your queries.
Sir, we have a question. Ma'am, can I ask?
Wait for a moment.
Okay.
Gopal sir. The participants are waiting for you. I know you can do anything. Yes. Yeah, have you joined? Ah, okay. आता मी ठेवून देते. Okay, sir, he is joining.
Okay. Till that time,
He
we
has
can
some
continue with the queries.
network issues. He is joining with his mobile. You can see him.
Good. Yes, Musina, please go with the queries. You have.
Yes, ma'am, we have a question from Saurabh Raj.
Yeah.
He's asking when the VNMVK conducted pilot drone technology as it mentioned on university website.
Yeah, all these related things you will get known with the Gopal Shinde sir. He is the PI and he is the person who is actually doing the training. He is the principal investigator and the whole course is conducted uh, under his supervision only. It's a 6 month training and a proper notification is published for the admission process. And you can get all the details from him. Have you received his biodata?
Yes, ma'am.
Yeah. He is joining with his mobile. He is having certain network issues.
Yes, ma'am.
He is an international figure. He has received the international awards and presently he visited last month. He visited Germany. And before that, he visited near about 20 or 22 countries and presented the work in their various international trainings.
I think he is also the professor and head of the department nowadays, right?
Yeah.
So
I
it
don't
is
know why. Shall I stop my sharing slide?
it's
Yes.
stopped, no issues. Dear participant, till the Dr. Sinde join us, you can ask your queries to Dr. Megha. He has done tremendous work in drone technology, so it will be a pleasure to resolve your queries because you are going to be like, I think, Dr. Saab, you can aware our participant about this Drone Didi project undergoing under the government of India.
Yeah. There is a subsidy for the women's and the uh, ladies that are doing agriculture and the uh, drone for the purchase of drone. It is the concession or you can say there is a subsidy for purchase of the drones and for them training is also with uh, the what you call subsidy is there, and that's why operation of agricultural operation in Maharashtra, what is there, the most of the operations they are being conducted by the women itself. Wedding, they sewing, they are with the help of woman labor. Yes, these are admitted.
Yes.
Okay, so I will stop my screen sharing, or you will stop from your side.
It's stopped, ma'am. You can close that.
Okay.
Hello, namaskar, Dr. Saab.
Namaskar. Sorry for the delay. I'm facing a network problem, and also we have a Avishkar program at a state level science exhibitory competition for UG, PG, PhD students. So I am here to start my presentation. Without
Ex
wasting time, I will have some quick demonstration to make my another device. I will keep my discussion live with the two devices, and one is my mobile and another is this PC. So I should get back to these all things which are to be now I need to present.
Okay, excuse me, Daksa. I want to interrupt
Yeah.
you.
Is
Actually,
it
we
visible
request.
now? Is it
Yes, sir.
visible?
Yes, sir. It is visible, sir. You can make
Okay,
it to full
okay,
screen.
okay. So with a very
So,
short time, I was just unable to make my all the things prepared. So thanks for
Sir,
inviting me.
Gopal sir, let him give your introduction.
Yeah, sure.
yes,
Everything I will
please,
do.
please.
I will do. I will just now start
Okay,
to make my
actually,
presentation.
Dr.
So
Saab, we want to formally introduce you to the audience. So please wait for 2 minutes, please.
sure, sure.
Okay, okay. Thank you, Dr. Musina. Please conclude the session one and go ahead for the session two.
Okay, sir. Thank you all the participants and on the behalf of the organizing team, I sincerely thank Dr. Megha Jagtap for sharing her expertise and valuable time with us today. I would also like to thank all the participants for their active presence and engagement. This brings us to the conclusion of the first session of day 28. However, today's learning does not end here as we are moving forward to another closely related and equally important topic in our next session. We will now be proceeding to the second session of the day. Now it gives me great pleasure to introduce our speaker for the second session of day 28. We are honored to have Dr. Gopal Uttamrao Shinde sir, a distinguished academician and researcher currently serving as professor and head of Department of Farm Machinery and Power Engineering College of Agriculture, Engineering and Technology, VNMKV, Prabhani. His areas of expertise span agriculture mechanization, CAD, CAM, CAE, automation, agri robotics, agri drones, AI, and machine learning applications in agriculture, operational research, and digital technologies in farming. He has played a significant role in integrating advanced engineering solutions into agriculture systems. Dr. Shinde has an impressive research profile with over 30 research articles, several technical publications, book chapters, and research recommendations. His work includes impactful studies on precision agriculture, UAV based weed management, nano sensors, agriculture drones, and smart farming technologies. He has also contributed to the development of innovative agriculture machinery such as multipurpose flexible cultivator, manual nutshell machine, engine operated earth auger, and advanced boom sprayer systems, demonstrating strong practical and field oriented innovation. In addition to research, Dr. Shinde has received national and international recognition, including roles as keynote speaker, session chair, best faculty awardee, and international conference speaker across countries such as Japan, China, Belarus, and Hong Kong. With this strong blend of academic excellence, research innovation, and real-world agriculture engineering application, today's session on application of robotics in agriculture promises to be highly informative and forward-looking. I now warmly welcome Dr. Gopal Uttamrao Shinde sir and invite him to begin his session. Sir, over to you, please.
Thank you. Uh, Thank you for inviting me from Agri SAARTHI, KRANTI, and this is a privilege to have an introduction in Haryana, specifically at a junction. My colleague, Professor Dr. Megha Jagtap, she introduced me just today. I was busy, but however, it's like for me to have this is an opportunity to make myself introduce first. Myself, I am Gopal Shinde. I am working as a head of Department of Farm Machinery and Power Engineering, as well as I am looking after the World Bank project, which is prestigious projects honored by Honorable Government of India and Indian Council of Agriculture Research. This project is aiming to make the digital technologies applications for making a precision farming. And in fact, this precision farming includes robotics. In this robotics, field rover robotics, then agricultural aerial robotics, and also the automatic guided vehicles, sensors. And with this exposure, I was just trying to make exercise in last 5 years to develop these all technologies at our center. And our university is introduced to every part of the world. As I am also selected as a member of CIGR. This is a commission for the International Agriculture Research and Development. And recently I had an opportunity to work with the CIGR member. We were invited in Germany for German technology evaluation, and in fact, the team from the Germany and all other over the globe, they introduced me to make the presentation of those all things which are exhibitorily contributed by this university. Our university, Vasantrao Naik Marathwada Agriculture University, has developed this center of excellence with all digital technologies. However, the central attraction part for me is that the robotics and their applications, no doubt they are a very high precision level instruments, I mean the devices which are we are developing to make affordable in the context of the Indian agricultures, and specifically the farmers who can afford in India. So uh, the contribution that we have already exposed to present in European countries like Belarus. I was there as an invitee keynote speaker for their government organization to deliver center of excellence that we are working since 2019. The World Bank project, which was funded of 18 crore rupees, and we established the lab facilities, and we have made the trainings, demonstrative experiments. Students are fully involved. Faculties are also participating to develop the different technologies. So the kind of developments that, in fact, we are making the club of, cluster of all traditionally developing automotives, or maybe we are trying to make the interdisciplinary collaboration with the traditional engineering as well as agricultural state university participating scientists, faculty scientists from various fields. So it's privilege to introduce that the center of excellence is divided into into the different divisions, such as the climate-based digital knowledge support center, then seed and seedling processing nursery automation center, smart portable machinery center, food processing automation center, and instrumentation cell. These all the divisions we have made according to the participation of the faculty scientists from the various disciplines. For example, climate-based all technologies will be developed by the meteorology, agronomy, entomology, pathology. All those scientists, they are working to develop sensors-based applications. The seedling, processing, nursery automation, we are trying to build different types of vegetable, horticulture kinds of technology where the robots can work. The robots are also classified to various state of arts. Industrial robots, they are working in the in-house built up structure, and field rovers are working in the field where they are moving around the crops and then doing the operations. Smart portable machineries that are to be considered that only sensors and automation kind of things which is facilitated to the farmers who can be affordable to make their efforts and their fatigue minimized to operate the field operative such a kind of automation systems. Then we have some part working with the food processing where the robots which can be used, or maybe the kinds of technology that we have developed which are used to have a 3D food printers, or maybe the small the food processing value addition machineries. And in fact, those all things are classified into the state of art that I'm presenting here as a CDKS, climate-based decision knowledge support system, seedling, seed processing nursery, food processing automation, then smart portable machinery, under these three divisions which we have developed. So portfolios wise, the divisions, they are working for the agricultural robots, We call it as agri boats, agricultural aerial robotics or unmanned aerial vehicles. We call it as agricultural drones, and then automatic guided vehicles. So agri AGVs, they are here to see that those technologies which are nowadays we find in International Globe Agri Technica at Germany and various part of the European countries where the FIRA is also organizing different kinds of robotics. We have a connections and collaboration with more than 21 countries to participate by the faculty, professors, or the students for PG and PhD to work with the international organization. So it's like interest for the students to catch up the new era, and that new era will be making the automation systems by effortless operative mechanism. So we have a lot of things in the field to perform by machine, and the machine should be intelligent. So trying to build this such a kind of a machine, we need to make the programming part which is to be understood by the student. Then faculty are performing their experimental task. So the robots that though are which are we performing from soil bed preparation, sowing operation, interculture operation, health condition monitoring operation, and in fact the harvesting, which is very important. So doing these all operations, we need to catch up the artificial intelligence programming up to LLM, big database, and LLM. So the students are getting learn of how to develop the artificial intelligence. So we call it as a AAI. So AAI is one of the new attraction for those who are interested to catch up the new digital world where they have a lot of business as well as the services, job opportunities, I should say. So the kinds of developments that we are working with these different types of machines, I had an exposure and experience to work in the University of Florida, where the Citra farm where we perform the robotic applications. So we are using Jackal, Husky, these kinds of robots, those which are working in the field, and they are identifying the pest to detect the pest and then perform the operation of spraying for pest management. So this is one of the, you can say, the interest line for the students who are trying to develop their various types of applications using the robots. In fact, the kinds of drones that performs aerial applications, we have more than 15 types of drones where the students can make their self trained as a pilot. So we are also running the courses like a 6 months course for the drone agricultural professional course in the agriculture drones, where the students are, this is now third batch we are starting in the month of February. So the students who have already completed from this center, they got 100% placement with more than 2 to 3 kinds of job opportunities from the different industries. The students are getting learn of how to use the drone for image processing in the field crop. They are using the kinds of a mission planner, which where the drones can be automated and make the performance in the field, so that the drone can be performing spraying operation, then fertilizer application, then image processing application. Those things are which are newly attracting to perform more than these kind of operations like harvesting. Also we are trying to develop this track for the harvesting process also. So I am having these labs to deliver you or show you and how the different kinds of technologies we can develop in our center that can be experienced by use of the different types of robotic applications. So I have some kinds of technology developments where the robot arm is performing the cotton picking operation. So to pick the ball and make the image concentric application, that arm should reach to the cotton ball and pick the cottons properly. So this kind of the applications that we are developing, where the robots are used of the 6 degree freedom, and we have payload capacities of different kinds. So Jackal and Husky is having a payload of 60 kg, and Jackal is having a payload of 30 kg. Like this, these different kinds of drone components or maybe robot components. We are also having a facility of 3D printing where the students are imagining the different kinds of technologies that can be developed by the student themselves, and they can make the model prepare. So we have a CAD CAM lab. In CAD CAM lab, the computer aided design and modeling, solid modeling, the students are preparing and they're testing it in the software itself. And once the final confirmation about the analysis that this design is performing a nice operation, then we can go for printing the components. So thereby you can have a robot arm which can be printed, which can be used for the agricultural applications. Like this, students are developing different types of the fixtures, like a camera holding fixtures. They are making the design of the camera holding fixtures. They are making their all kinds of those applications which are not available in the market, and they are using it to develop the kinds of attachments to the robots. So students, they are not only doing these kinds of physical hardware developments of the robots, but they are also doing the kinds of research experiments. So for example, in the cotton, the pink ball arm worm is one of the difficulty, and one of the crucial period right now. Because of that, the cotton cultivation area has been lowered down. So students are making their analysis to see that how these robots can be used to perform the operations in the field, so that they can be operating to make the different kinds of camera applications as a machine vision systems, and those cameras which are predicting the image signatures. Accordingly, the image signatures are constructed to develop a LLM model. So just like I should say, the student should know how these spectral signatures, and then the signatures by different cameras like hyperspectral camera, multispectral camera, different types of a parasequential camera, where the students are performing their operation to make such that the online field, one can detect how many number of the pests are entered into the field, and they can count, they can make the GPS based location of the insect which are present on the cotton ball. So the spray count, the spot spray, that I should say, to make the spray on the entire field is wasting the pesticide. But this pesticides, if we spray it on the specific where the insects are traced by GPS system in the robot, that will be a more useful, and we can say saving of the pesticide. So thereby farmers can be economically benefited to get the spray count in a very less quantity, and accordingly the field can be best to make the health condition monitoring. So these kind of experiments, when the initial stage of the cotton ball, we found that will be immediately detected, and accordingly the precautions or care can be taken. So we are continue to make this research to find that the solution for this by using the robots can be a best productivity, means it is a best solution as a digital farming solution. So that is why we say DFSRDA, digital farming solution by robots, drones and AGVs. So DFSRDA center is again we can say we are also trying to build the students habit of developing different types of artificial intelligence modeling. So they are having these kinds of different AI, ML, DML, and LLM based project developments. So they are making the different types of experiments, and accordingly the models will be executed on the field background. So some of the students, they are doing a performance like in India, we have a lot of genotype, species which are specially meant for the patentable plants in the India, and those plants which can be created as a 3D model, and this 3D model will have all kinds of characteristics or features where you can say roots to the fruit, entire plant having a roots, I mean the stem, leaves, then flowers and fruits. All those things can be catch up and make their model such that we can make the presentable digital phenotype plant library. So this will be a universal plant library where the application can be mounted on the robots. So I must say the kinds of those things which are student performing is amazing, and I invite to join our courses in future. We are as planning in the month of February, March onwards to start some programs, online programs and offline programs also. You can say those trainings and hands-on skill developments program which will be initiating to develop the digital society of India. So these are all research that we are conducting by use of the drone or by use of the, you can say, robot. We can make these applications very well mounting. Another thing is that we are also trying to see the how it can be useful for the animal husbandry. So for animal husbandry, for animal husbandry, a animal, when it enters into the clinic, the patient's history should be known. So we are using RFID sensor based application which can work on Wi-Fi, and thereby we can have a mobile app, so that if the doctor is not available in the clinic and available at the remote place, immediately he will get alarm and he will let know what is the patient came in the clinic. In the meanwhile time, the RFID tag system, you can have a video conferencing with the animal, and this video streaming will be able to get the capture of the patient situation, health condition by the doctor in a remote place. At the same time, the treatment that can be a start immediately, as on the emergency case, the kinds of CT scan, then X-ray, then pathological test reports, all everything that can be that can be feed into this RFID system. So this is like a very interesting and this is like very interesting, and I should make the part of this application to run into the lab, and thereby we can see that how this part can be really genuine to the field of different kinds of the emergencies in the animal husbandry, livestock for the health condition monitoring. We are also trying to develop the farmers, as they can listen the voice in the field. When the robot enters into the field, then let farmer should know what are the situations in the field. So voice tag will be making them to alert that they should take ready, they should make ready of their system in the field ground, where the applications of the spray, applications of those part which are very important to make applications, this they will let know immediately what is the emergency. So accordingly, I must say these are the things which are developed and presented in the international conferences, forum of the scientific group, and the students are now called for the interviews to get their further studies in their countries. So like last week we are having the interviews in the Germany. There before we have interviews in the USA. The students are able to explain their scientific research to the different professors of the different university, and thereby they are qualifying actually to make their presentation to work. They are acquainted with the advanced technology. So I have a lot of presentation, and then this lab facility which we have developed. So we can have another session to make these all things presentable. I must say the technology that are developed, which are finally going to get it running into the field ground, and if they are working with such a kind of applications, so that that will be a new era where the job opportunities can be open up. We are having a grafting robot. This is another kind of application. In this grafting robot, we can take a brinjal as a rootstock, and then tomato as a scion. So we can make the different species of their genetically matching with their grafting process. And this grafting is done like for a day shift, 8 hours. We can have 4 to 5,000 grafts by use of the single operator. And this is another machine that is we are using. It is a Korean machine that is a grafting by using the HSC, where the two operators are used. So single operator, two operators. These plants which are developed, you can see in this picture, the students are taking these grafted plants to the field, and then you will find on the same plant sometimes you can have a variety. We have plants which are developed where the tomato and brinjals can come together on the same plant.
Dear participants, sorry for the disturbance. Dr. Shinde rejoined, and he will continue with the lecture. Please be there for moments. Hello, Dr. Sahab, are you there? Dr. Shinde, can you hear me?
Sorry for interruption. Am I audible?
Yes, sir, you are audible.
I'm audible.
Yes, sir, you are audible.
So, yes, am I audible now?
Yes, Dr. Sahab, you are audible.
I'm audible.
Yes, sir.
Am I audible?
I think your internet is not stable, Dr. Sahab.
आपका एडमिट है नहीं हो इसलिए एक्सटेंशन बोर्ड जाएगा कहाँ कहाँ गया इसके बीच में रखा
Dear participant, till Dr. Shinde arrange some alternate way to present his presentation, you can note down the queries
audible?
until the time. Yes, sir, you are audible.
Okay, sorry for interruption because I told you no the whole thing like I'm managing front camera.
So, is it possible to present from your side, or we need to present on your behalf, Dr. Sir?
No, it's like I'll just first of all demonstrate these things. and
Okay.
make this camera on the front.
Yes, yes. You can do the back camera. It will be better.
Yeah, back camera. Yeah.
Yeah, please.
Web पे चल रहा है.
So I'm just trying to make myself
Ji, Doctor Saab, it's visible.
visible. Okay. So just like this is the aerial robotics systems that we are trying to build a system such that the different type of applications can be made by using the 3D printer. So this is the 3D printer, and we are having the aerial robotics lab where the drones we say the drones that are applicable, and then the sensors lab, then this is for use for the uh, this is used for the development of technologies using the different types of sensors, and a robotic arm positioner where the robotic arm for positions making we can use this is the test kits for the students who can take their part of developing the different types of applications. So the more interested part is that I must show you the grafting robot. So grafting robot, which is we are using it. Okay. So I must say my laptop is also off because I just now can rejoin, and now I'm going to continue the presentation. उधर रखो. So I speed up to make the presentation as fast as I lost the time. Is it now able to reconnect me on my laptop? I'm checking just. So again, I have joined this link. I think I
Doctor
may be
Saab,
pleased.
actually, you can take time and we can be little slow because it will be better if the participants get benefit out of this lecture. So need not to be hurry because participants are very cooperative in this regard. So you can
Okay,
take
okay,
your
okay.
enough
I
time,
just
Doctor Saab.
thought
No issues.
no problem. So I can be slow.
Ji, Doctor Saab. Dear participants, Dr. Shinde is here to present his presentation. He will continue with the lecture. So please be there because it is a very interesting topic. We are eagerly waiting for Dr. Shinde to continue his lecture.
So, I was just trying to show you. Meanwhile, this grafting robot, we are trying to make it ready. The students are developing a small rover robots for their experiments, and they are developing the artificial intelligence kit where the students can learn how to make this a prototype experiment that can be magnified and that can be further able to work. So I kept all those videos in LinkedIn. Also, you can see in the Facebook. My LinkedIn and Facebook account is Gopal U Shinde. So there you can find the students are developing very small, smart kits. They are developing the smart, sensors-based application where the soil testing, which is we can do, and we can see that display, and accordingly the students will let the programming done, and these chips will be inserted to the circuits. So I'm just trying to make yourself alive that as good as you are visiting this center, and you'll be able to learn what are the things that you have to go for, proceed further for their different applications. So interest line is like the student are those who are coming up and understanding the process, agricultural process, and then let them program it in the proper way so that your data bank and your developed model will be working with the robot. So I am targeting to develop at least 10 number of technologies to get help of the kind of automations which can be affordable for India to deliver these technologies to the farmers. So this is like a challenge, and this challenge can be taken up by you, like all aspirants who are on this platform. This is a planet, and this planet yours. I'm really happy that Krishi Kranti, they have taken up these all participants to take their interest in the robotics. So we have the group of meetings, clubs. Students are trying to develop their technologies, and I was just trying to show you that when we develop such a technology, that should be used to the farm practices, and the farm practices will deliver after confirmations of all those experiments which are confining the results. So I was just trying to show you. Is it visible?
Yes, sir.
Yes, okay. So I was just trying to show you that the kinds of developments. Now we have a Japanese scientific group. They are from 100 years of old. They are developing such a robotic technology, and they are making us as a partner, knowledge partner, for developing their future robots. These future robots, where the different types of graftings for the different types of horticulture or vegetable crops, where we can develop different types of new varieties. So no doubt the applications that in the field ground for the students, they can play different types of experiments as a game, and they can see that in the field, if the robot moves in the field, the robot should count the plant, robot should count the fruits, robot should count the the flowers if they are present, and into make their application as a state of art, that the farmers will get display on his mobile that how many number of plants are available in the field, so that his attraction towards the productivity will be more curious. So if the farmer knows that he is having a 10,560 plants, all those 10,560 plants, they will be a client, and then every client for the maintaining the
Hello.
So I like to show you this video. Please see this video, which is been presented by Indian Council of Agriculture Research by our Honorable Prime Minister, where you will find all those robotic technologies they have taken up from our this center to deliver it to the national and international forum.
It's into e-commerce.
Is it audible?
Shraddha is a student studying overseas. And Asia is a farmer. If we ask, who among these people work in the agriculture sector, most of you would say the last one. Our answer to that would be wrong. Because the correct answer is, every one of them is associated with the agri sector, employing over 75% of the 770 million people in rural areas. The agriculture sector of India is nothing less than an ocean of opportunities in as many as 13 domains. Let's work towards cultivating futures in agriculture, a promising path ahead. Close your eyes and imagine a future where you are the driving force behind India's $5 trillion economy. Our visionary Prime Minister Shri Narendra Modi believes in the power of youth. The youth. The dream of Viksit Bharat 2047. Inspired by this vision, the Indian Council of Agricultural Research is working tirelessly towards strengthening and development of higher agricultural education in India, human resources development for leadership roles in agricultural sciences, improving quality of agricultural education through innovative approaches, program. It's a game changer. From experiential learning in business mode to hands-on training for skill development, from rural awareness work experience to in-plant training and internship, the opportunity are with developments in the sectors. MOUs are signed with industries for knowledge exchange and experience sharing. Holistic development of thought under.
So this is like we have a contribution in this video that to make the developments and show the technologies to the aspirants who are really like to develop their careers. So I just had an opportunity to show you the grafting robots, how is it works. So can you be there with my another device which is connected? Is this connected? Deepak? झालं तिकडे ready? दाखवा इकडे.
Thank you, sir, for your truly futuristic masterclass on agricultural
Excuse me,
robotics.
Chatri sir, please excuse me. Dr. Shinde is not yet finished. Dr. Shinde, can you tell me the device name so that I can make you the co-host and you can present for the crafting robot?
Will you please join me on my another device, Ajay ji?
Ji, Dr. Saab, what's the device name? Can you please confirm so that I can make a co-host? By
Just
which
now,
name you are trying to join?
yeah, I am just trying to connect this. My device name is iPhone.
Okay. Susma, I think it belongs to Susma, right? Hello.
I think my another device is not connected yet. My mobile, actually, it is iPhone, and I just connected. But anyway, now I have taken up this laptop itself.
Okay, and Dr.
Show
Saab,
you
can you
if it
please
is
remove?
visible properly. You can
Yeah, can you
see if
please?
it is visible properly.
Excuse me, Dr. Saab.
Is it visible?
Hello.
Yes.
Dr. Saab, can you please remove this blur background because it is creating problem in the visibility.
Oh, sorry.
Yeah.
This blur. Oh, blur. Is it visible now?
It is visible but not that much clear.
I made it none.
Can we stop this screen sharing, Dr. Saab?
Yes.
Okay, so now you are full screen and you can go ahead with the showing of grafting robots. Please.
I think I can just show you. This is a grafting robot. Deepak असं धरतो. Is it visible?
Ji, Dr. Saab, it is perfectly visible.
Perfectly visible at this position?
Yes, yes.
Okay. So this is the robot where you can have a the two plants where the one is your rootstock and another is a scion. So rootstock and scion, if we keep them both together, you can see
Uh,
that if
Dear
you need
Deepak,
to
please
just
move it towards Dr. Shinde because he is not visible. He's
is it
showing very
visible?
bold. Please turn it little right.
थोड़ा सा पड़ेगा. Is it?
Now it's visible. And
Okay.
it will be better if you move little back also. Then also it can be visible clear.
थोड़ा समझ गया. Is it?
Yes, Dr. Saab. Yes, please.
Just a quick process. I'll tell you. This works on the pneumatic compressor, and with the pneumatic compressor, this is the clipping process. You can see that this clipping process is by using this clip which is cutting at the junction when you start the operation. So there are two rootstock and side. There are two plants. We are holding in this fixture, and then we are pressing the button. So once it is pressed, this is get clipped. So this is clipping both the plants. I can show you the plants how they are.